Welcome everybody to the second cyber systemic interaction. Now today, Massimiliano Pirani, Andy Williams, and Žan Domanjko will introduce the topic of the holonic VSM as a path toward the connection of human artificial cognition, which does relate to the first cyber systemic interactions. Maybe a hint about how to interact. You can interact with everybody if you choose to, but also if you decide that you would like to talk, to discuss, to comment something with a person in that group, come on, feel free and write a personal note to that person, and maybe you can develop some kind of a direct discussion and then share it with the rest of us. Maybe even after the short cyber systemic interaction. Maybe we should start by explaining some of the core concepts by Žan Domanjko. Žan, would you like to share the screen or should I do it for you? Okay, yes, Žan, your 5 minutes is on.
Okay, today's topic is about viable system model. This is a well-known model of organizational structure of an organization. It consists of actually 3 parts. The first part is E, environment, then O, operations, and M, management. At the same time, it covers five systems. The first system is the implementation. The second system is coordination. The third system is control. The fourth system, intelligence, and the fifth one, governance. The advantage of the VSM model is certainly the standard structure, which enables us to easily understand the situation, and also it's possible to replicate the model in both directions, in vertical and horizontal. In vertical direction, we can use the recursion of system 1 in solving complex tasks with the help of several VSM systems. So as children of main VSM model. On the horizontal direction, we can also generate several VSM models as autopoiesis or self-reproduction, which solves the problem of largeness of a problem. On this picture about holons and holorchies, holons can be understood as autonomous and self-sufficient subsystems that have the ability to make decisions. For example, complex agents, people. Holons can be also combined to holorchies, a recursive hierarchy of holons or tree of a tree is called the holorchies. The view of holorchies as a holon is called the Janus effect.
Thank you for the introduction. Let's see if Andy can follow up. Okay, Andy, can you please explain what's your perspective on the VSM?
So I did not hear a word Jan was speaking because of connectivity issues. So can you confirm that he explained what the VSM was?
He explained the structure of the VSM, the general structure, very briefly, and standardization, basically the standard form, and the capacity to self-reproduce either via recursiveness down or via autopoiesis on the left and right. So those were Žan's words on VSM, and then he connected that with holons and holorchies.
Okay, perfect. So I'm actually connected in two ways. I'm connected with my cell phone, and the cell phone has terrible connectivity. I'm also connected through my computer, and unfortunately my computer has no camera. So what I'm going to do is, since the computer has much better connectivity, I'm just going to speak even though there's no. So as you heard from Jan, the VSM's an approach in cybernetics developed by Stafford Beer. It's based on the idea that any viable system must have a certain structure to perform its functions effectively. The model is divided into 5 parts or subsystems, even with its own set of functions and responsibilities. And of course, as you said, holonics is a term that describes the study of holons, which are self-organizing systems that are simultaneously whole entities and parts of larger systems. So holons are building blocks of larger systems. And the VSM is itself a holonic model. Now, human-centric functional modeling models the human organism as consisting of a hierarchy of systems, and each one of those systems represents a separate domain of human functionality. Processes in the human organism, from unconscious ones such as homeostasis or cellular reproduction, which also called autopoiesis, to conscious processes such as sensations, emotions, cognition, and awareness, are all represented in human-centric functional modeling as each moving the human organism through the functional state space of that subsystem. So comparing VSM to functional state space with regards to modeling cognition, the benefits of the VSM are that some people have found the VSM useful for analyzing and designing complex organizations, and they found it useful for identifying areas where changes may be necessary to improve the viability of organizations, as well as to ensure the long-term survival of an organization in a changing environment. Now, the drawback with the VSM, or the drawbacks, are that the boundaries between one holon and another essentially define an ontology that could be chosen that could have been chosen in a very large and potentially infinite number of different ways. Now, all of those possibilities are described in human-centric functional modeling by the conceptual space when it comes to modeling the functionality of cognition. So now, assuming that neither the VSM nor any other ontology can span the entire conceptual space, in that it's able to encompass any 2 possible concepts, and in that it's able to represent any possible reasoning explaining how any two concepts interact. Given this is true, the VSM cannot be a complete systems model, just as no other ontology can be a complete systems model. So any 2 systems models that are incomplete cannot be completely compared. So if you have a systems model for the left side of the room and I have a systems model for the right side of the room, unless both of those models are for the entire room, you can't completely compare either of those models. You can't completely compare those models. So therefore, there will be part of the system that can't be compared. Any systems model that is incomplete cannot necessarily be used to understand all other systems models in order to converge on a single complete understanding of any system, including cognition. Now, here is the key point. A key challenge in cybernetics and systems thinking is that there are already so many approaches to understanding systems. The relationships between these approaches haven't yet been fully explored because the collective capacity of the community to explore and compare all of these approaches is limited by the complexity and, in some cases, the impossibility of that comparison. In other words, the most important direction forward in systems thinking and cybernetics, might not be coming up with new and better theories in systems thinking and cybernetics, because the community simply doesn't have the capacity to evaluate and compare them. Instead, the more important direction, or the most important direction forward, might be figuring out how to increase the collective intelligence of the community, and therefore increase the community's capacity to make these comparisons, so that it's possible to collectively converge on the understanding of systems thinking and cybernetics that is most fit in describing the world. Let me just summarize with one sentence. If it takes 1,000 questions to be able to determine whether or not a given systems thinking or cybernetics theory is viable, and if we only as a group have the ability to reliably motivate ourselves to ask 10 questions out of those 1,000 questions, we can't reliably assess any systems theory, any systems thinking or cybernetics theory as valid or invalid. That's it.
Okay. Thank you, Andy. Well,
Sure.
there is quite some truth in that, but I think it will be a great debate opener. But let's finish the trio of the presentations with Massimiliano. Massimiliano is leading this discussion today. So yes, welcome, Massimiliano.
So I recall our exercise. I have not, so I initially posed this problem, and we have seen the views of Žan and of Andy, now how they have interpreted this problem. The fundamental problem is quite practical that we want to pursue, is can the viable system model, which is well known and applied many times, but can it constitute also a general structure for the realization of hybrid reality cognitive system? So the question that we today try to answer, but not today only, today we will debate and learn from every one of you, but it is a research that we are doing, we intend to do with also some projects, is to try to use the VSM to capture the cybernetics or the cybernetic essence in the hybrid reality phenomenon. And with hybrid reality phenomenon, we consider the new reality that is happening now, that sees a closer interaction between the machines and the human. Today we know we have great computing capabilities and applications that also in some way seem to us a little bit risky. But we have the humans that feed them at the end of the day. So this contact now is the new reality that we are facing. And so we try to understand and to control, of course, in a cybernetic sense, this phenomenon using possibly the VSM structure. And also the VSM is good as a model because, you know, when you want to insert for a certain part to have some semantics grounding in cognition, and so try to do some engineering of it, you cannot solve it in fine steps because you have level and meta levels occurring in the infinite regress usually. And so the recursiveness of the VSM is a key to that. So what we want to put forth here is that holonic interpretation can be used in this context as technology enablers for what is the amplification and attenuation, the variety that is a part of the VSM model. And also to see this recursive instantiation of the VSM as a holarchy of cyber-physical system of systems, which means for me, cyber-physical is the contact between the artificial and the natural in a more general sense. And also the holonic architecture could be the basis of an execution model of the VSM. In practice, for example, we have engineering practice For example, we have other notation like BPMN for process management, and BPMN, for example, has achieved an execution model. An execution model, so a software that communicates with the participant in the model, and the actions are synchronized, verified, and so on. And so the same we wanted to try to make with the VSM model. That is the model that can capture the whole phenomenon of a cognitive system. In particular, initially, we are trying it in the construction sector, but we are using it in all the sectors where workers are side by side with machines, and not only. In the figures, I wanted just to use the same picture that Jean showed us, but I wanted just to fix one definition. The holon for me is this entity with Janus phase, so double phase, but the holon is the connection between the two layers, so the whole, a whole, and parts. So is an entity that has these two sides at one time. And if we map this with, for example, this first holon with a VSM, the holon, we can place the holon here where there is the connection between the operations and the head, let me say that in a simplified way. So we have a lot of parts interacting and acting, and they are controlled, they are integrated by the holon. At the same time, the holon is that, let me say, is the element that is between two parts that where the variety changes. For example, when you have an amplification of variety, you have a structuring of a system. And when you have an attenuation, you have an abstraction. In some of my recent publication, I used the concept of category theories also to show that. When you have an amplification, you have the structuring factor. And so you have something that augments the states of the system, the complicatedness or the complexity of the system. In the other sense, we have a filter. As Koester, Arthur Koester, the creator of the holonic definition, says, we have filters that make an abstraction of the parts into the whole. Let me just mention here in this beautiful community that these pictures were taken from a very great book. I enjoyed very much reading it. That is from Vanilla Beer and Aliena Leonard, and this is the Stafford Beer, the father of managed cybernetics, which I advise to read very soon to all of you. And I extracted these two pictures in the homage. So I leave the floor to the debate now.
Thank you very much, Massimiliano. Now, before opening the floor, let me just express my astoundedness that we are really living in these crazy times where people are now facing AI. But this AI we are facing is framed in centralized big AI systems, which do not necessarily serve us. So I think the question is, should these AI systems be all looked like that, big centralized systems? Is there a chance to do something distributed, something adaptable, something which actually has a general structure which can be shifted, not being centralized, being distributed? Maybe, let's see. Viable system model structure might be one of the main keys to accomplish exactly that. Saying that, I'm opening the floor for participants. Yes.
I am very keen to understand the connection between VSM and hybrid reality. From what I understand so far, the idea is that there is a world of where the parts are not connected in the sense that we see in a viable system. These are parts that are somehow operating with some forms of amplification and attenuation, and they go back to generate or give the chance for a viable system. So on the whole, I would like to hear far more from Massimiliano. What is the difference between the hybrid reality and the viable system model?
Okay. There is not a difference, but in my view, I wanted to use the structure of the viable system model in order to have a means to understand and to control the phenomenon of the hybrid reality. Because in the hybrid reality, we have to connect and to study the contact between something that is artificial and something that can be natural. And this contact can happen at very many different levels. At the level of reasoning, at the level of operation, at the level of management, because now we have artificial means, so softwares or artificial intelligence, narrow artificial intelligence, to, for example, as decision support system, or as robotics that do operation, or as, let me say, prostheses that augment our capabilities to know, to reason, and so on. So I see it as a structure that can come across all the layers of this phenomenon of the hybrid reality.
So if I understand you well, you are saying that the viable system model is a structure
Yes.
to connect the multiple parts of a hybrid reality.
Yes, also.
Hybrid reality are many different pieces of software, many aspects of action in society, and they are somehow separated one from the other. And suddenly we have the VSM as a means to connect this hybrid reality in something that can give meaning and improve the situation. Is that a significant or correct interpretation?
Absolutely, absolutely. And when we have this possibility to model more effectively, we, of course, can think about controlling this system in a better way that we can achieve today.
Thank you, Massimiliano. Thank you, Raul. I see a hand risen by Alexander Rekov.
Hello, Alexander.
Glad to see you. I have not seen you for a long time.
Yes.
I think that I very thank you very much for your very interesting lecture and talk. But it's I have got a very strange question. Very strange, as usual. I saw a lot of structure, and many words, But as I know, any good science or branch of science has its own fundamental laws. For example, you are talking about conceptual space, cognitive semantics, hybrid reality, and And I think all fundamental laws in this cybernetic structure we took from other science branch, from physics. Or, for example, cognitive reality or cognitive semantics has a non-local character. Our mind connect with different spaces. It's from physics. I bet it's from physics. What can you tell you, and what do you think about possibility to use the fundamental laws in your presentation, in your holonic, for example? I see only structure, but new words, holonic, very good word. But where is the fundamental laws, like Schrödinger, like and so on, for example? Or we don't have any laws. We have only structure. We have only good words, but we cannot make any forecasting. Okay. What strange? Perhaps I'm talking like physicist. Perhaps it's my mistake. Thank you.
Thank you, Alexander, for your question. I try to answer, but it's difficult as usual. Okay. It is the laws, what you mentioned, and the physics part usually intervenes as the microsystems, no, where there is the complex interconnection between things. But when you have, for example, if you speak about particles and things like that, and at some time when the human is in contact with this physical phenomenon, you have, for example, what is called usually the decoherence effect in physics, no? When you pass from the quantum situation, for example, to the macro and natural classical view of it. In this case, there is a holon in between for me that sees the parts and the decoherence effect as a whole and has to manage both in this system, and it can occur at a very different. This contact can occur at very different levels because of the vertical recursion in part of the VSM, but also in horizontal recursion, as Jean said at the beginning. So there are two effects: is the autogenesis, so parts that control and produce other parts, but also autopoiesis, so the contact with the environment, for example, that lets any part in the hierarchy stand in equilibrium with the physics, or not only the physics. Maybe the problem is dual. Not only we have something that sees the world of the parts as a physical system, but maybe a digital system. Let me make an example. If you consider an artificial intelligence for us, for example, for this artificial intelligence, the physics, they are the physical world, and the virtual world is you that feed them with information, with nutrients. Or is it the opposite? It depends on the way you see the systems and the structure that you attribute to them. So maybe if you do, for example, a simulation that has a physics inside, it is a world where you can ground your observation and make reasoning and make predictions and so on, the cause effect and so on. But it can happen at very, very many levels. So there is also one level for the science and the models of classical or quantum physics. There is a level for the science of management. There is a level for cognitive science and so on. This is the greatness in the structure of the VSM.
Oh, thank you very much. I think
thank you, Alexander,
we will discuss follow to discuss this problem. Thank you.
Marcus, you have your.
Thank you. I have a question to Andy Williams. You said something interesting. You said that the VSM doesn't provide a complete model of the functions of cognition. Probably completeness is not the issue here. But I have a question to you. Could you tell me what are the essential or the critical functions of cognition which are missing in the VSM?
Okay, from my point of view, the functional state space approach says that any system can be represented in terms of functional states and the processes used to transition between those functional states. And all of these functional states form a space that can be used to represent any possible behavior of the system. In the case of the cognitive system, the functional states. Who am I speaking to, by the way?
Marcus. Here I am.
Marcus Schwanniger.
Yes.
Can you wave?
Yes, Marcus is waving.
Okay, I see. Sorry.
Yeah.
I was looking on page 2. You're on page. Hi there, Marcus.
Hi.
So, so from this perspective, any behavior of the cognitive system can be represented as some path through this conceptual space, which is the functional state space of the cognitive system. So these functional states are concepts, and the processes between them are reasoning processes. And these can be type 1 or type 2 reasoning processes, which psychologists have found or have confirmed represent all possible reasoning. So to answer your question, all possible reasoning processes are simply represented as a path through this conceptual space. And when you talk about what behavior of the cognitive system is potentially not represented within VSM, I would flip that around and say, can the VSM potentially represent every possible reasoning process in the conceptual space? What would your answer to that be?
Well, no, that's clear. But I would like more about the critical variables in this game. It's in our realm, in our domain, models are not complete. So all the more we have to concentrate on the essential variables, as Ashby called them.
Okay, models are not complete, but spaces are complete. So there's no model in any space that's complete, but the space itself can still be complete. Would you agree?
Yes. I don't see any necessity to capture the whole state space in a model in all details. I have to live with abstractions, with boundaries which I can set and reduce the state space. So I'm not comfortable with the statement that a complete or that a good model, let's call it like that a good model is missing, and not giving me any place where I can start to.
No, I understand what you're saying.
Prove the situation.
I agree. So there are some key elements. So there are some key things of importance in the functional state space approach that are missing in the VSM approach. So the fact that the functional state space is complete means that you can understand properties like intelligence, for example, in terms of the volume of conceptual space, the volume and density of conceptual space that you can navigate with reasoning in order to, per unit time, in order to solve any problem. So you can't take that same definition and express it in terms of any ontology like the VSM. So in other words, the definition of intelligence doesn't exist, or that definition can't be expressed in terms of the VSM. It can only be expressed in terms of a functional state space of cognition that is complete. Does that make sense? So if it's useful to have a definition of intelligence, that is a definition of general problem-solving ability, which is a key element of cognition. If it's useful to have that, and I say it's incredibly useful, then you can't have that without a state space-based model. Without a state space model, you cannot have that with an ontology-based model like the VSM. So the VSM may be great for some things. Not saying that it isn't great for some things. It might be amazing for some things. Having a subset, having the VSM as a subset of possible models is a very great simplifying approach. But that simplifying approach doesn't allow certain problems to be solved. One is understanding properties of cognition, which you can only understand when you try to express those in terms of the functional state space of cognition, that is the conceptual space.
I have a question here. I think I can follow you, but my question now is, how do you instantiate a model of this functional state space?
That is,
I mean, you are giving us concepts, basic concepts, but can you go further?
yes, I believe so. So in the picture I have of this functional state space in my head is that these concepts, which are the functional state space of the cognitive system, are distributed throughout a three-dimensional space. And in this three-dimensional space, the distance between concepts is the degree of similarity between concepts. So it's their semantic distance. So at the same time, these concepts are distributed throughout three-dimensional space, separated by a semantic distance. They're also connected by a four-dimensional network in that there are four operations that can connect any one concept to another, so that any reasoning process is a composition of those four operations. The importance of that is that there are already tools. One is called ConceptNet, that's able to represent conceptual spaces and store them as databases. So what I'm trying to do right now is to translate this concept into one of these tools like ConceptNet. Tools like ChatGPT, large language models, already have some representation, some internal representation that's like a conceptual space. It's just a matter of taking that representation and translating it into a tool like ConceptNet. And that's what I'm trying to do right now, but we just need to find the right expertise.
So are you talking about semantic maps?
A knowledge graph, I'm not sure what a semantic map seems like a subset of a knowledge graph. Mm-hmm. I'm not quite sure what it is, but yes, I'm trying to implement conceptual space as a knowledge graph.
Well, I think just to thank you, I think it would be interesting at some point to see these more concrete instantiations of your theoretical basis. Thank you.
Thank you.
Thank you, Marcus. Thank you, Andy. Maybe just a short comment. And I might be wrong, but viable system model is basically a structural model, right? It provides structure. And the content can vary from organizational to personal to all sorts of things, and can also include reasoning and creating maps of reasoning as such. So this does not exclude itself, but you know, each model has a purpose, and that, you know, VSM, I find it very good in providing structures And this is what we were trying to discuss here. Yes, Lowell, I'm sorry for keep you waiting, but
Igor, thank you. I like what Andy is saying, but I think we have missed a major distinction in cybernetics. The distinction is between machine cybernetics and living systems cybernetics. So if you look at what the viable system model does, which it does very nicely, it has the environment with its own logic space, its own activities, self-organization. It has the operations or organizations that interfacing directly with it. And then you have the regulation or government management side overlapping with it. What is happening with ChatGPT is something different than saying it is a representation of reality. It is a representation of our cognitive space. So I'll just put up some, there's an Italian artist that is put to ask ChatGPT, tell me about the history of Western art or art. And what ChatGPT did was show how it went from cave drawings through the Christian, Egyptian, etc. But it comes up with a mirror of the limits of our own lens that we see the world through. And I put in the chat the, you can look at this several minute ChatGPT representation of what Western civilization. So we can use a ChatGPT to provide a reflection of what we are actually conceptualizing, because it looks at its own conceptual space and analyzes it quite well. It is not necessarily a connection to reality. So there's a major difference there. So just an example, a new study just came out looking at mapping the mind, speaking German and speaking Arabic. It utilizes totally different parts of the brain in the language. So this goes to the one concept I would love this group to talk about, which is Conway's law. It comes out of software area where I come from, which says the design of your system will mirror your communications system, your language. That languaging forms our ability to see. And so we have to be looking at that Conway's law and using cybernetics of the machine to give us a mirror of where our limitations and boundaries are, because it can actually formulate it. It is not a representation of reality and how we conduct wars necessarily.
Thank you very much. I agree that because you don't have to follow up to both of you, Lowell and Igor. We don't have the VSM as a fixed model, but it is a structure that goes up and down indefinitely, and in a constructive way, adapting and creating the reality, because the hybrid reality is something that we create, does not exist by itself. But there is also another raised hand.
So yeah, how are you?
Yeah. Hi. Yeah, thanks. Hi, God. Yeah, I have a question for Andy, please forgive me if it's a repetition of some of the things that have been discussed. The question is, you know, in your opinion, how is the functional state space embodied? Because if something can be embodied, then we could attribute purposes to it and hence apply tools such as VSM. So I'm curious to know how, in your opinion, the functional state space is embodied.
Can you clarify what you mean by embodied? Do you mean implemented?
Not specifically, because I mean embodied in the sense of an embodied intelligence. Because when we talk about cognition, I think it is important to talk about embodiment. Otherwise, we're talking of conceptual models, and you know, what makes the functional state space model alive and hence amenable to design.
You said what makes it alive?
Yes, for a lack of a better word.
Okay, and so what is very powerful about this approach is that you may or may not be aware, but some people don't even believe that cognition exists in the mind. Some people believe that that we move through some sort of a mental field and we are in essence antennas. Other people feel that cognition is simply a biological function of the brain. So there are so many different ideas of how cognition arises. I sidestep all of those and say, regardless of where it comes from, let's just look at what it does. Let's look at its functions, and let's form a state space of all its functions and all of the states that those functions can allow it to move into and move from. Once we can create this functional state space, we can describe what exactly we mean by cognition, even if we have no clue whatsoever how it's implemented. So when you talk about embodiment, it's really, really important to separate the question of embodiment from the question of what cognition functions to achieve. That's what this functional state space approach is all about, understanding simply the function of cognition. So with regards to understanding it from the VSM point of view, same thing. It's important to understand what the VSM functions to achieve, and understanding that separately from any particular implementation of the VSM that achieves that function.
Thank you, Andy. Thank you, Sujay. So you're satisfied? You can always follow up and chat with Andy and go on with the interaction afterwards. I can see Boris saying something.
Yeah. Hello. I have only a little remark. I studied holacracy in the Organization of Enterprise Management in our country. And the goals of holons and the goals of organization are very difficult to harmonize in the practice. But using a detailed competence metric that allows you to manage and adjust the process of self-organization with the goals of organization at whole. People, holons, and organizations have competences, and the correct competence model can serve as a condition for the stability of the holonic structure. It's my experience. And as for AI, I think it's just a tool that people can use. It can be used both in holonical structures and in hierarchical ones. Thanks.
Thank you, Boris. Any comments, Massimiliano?
Yes, I would like to follow up to both the comment of Boris and the former one. Boris, yes, you're right. Holons are very difficult structure to implement correctly, but they anyway represent a placeholder where to look at to implement those kind of hierarchical system, dynamical hierarchical system. So we, in a certain sense, we do not have many alternatives to make this approach pragmatical, no, into pragmatic. And also the same thing holds for the other comment. Yes, everything has to be embodied, and the VSM as the body in itself, which is the system one. So every system is embodied in a system one. And this embodiment happens possibly infinite levels, infinite semantics levels. So abstract levels, physics levels, as I said before, and managerial levels, and so on. And so for the strength of the VSM that I acknowledge is this capability to have a body at any level of semantics.
We're slowly getting to the end. No, well, it is 1 hour. Before handing the words back to Massimiliano to finish the session, the next time we would like to discuss the role of people in this system, where we have proven to have some general artificial intelligence, which is monolithic, centralized, feeding on the data people provide, because without this data, it could not actually connect to people and suggest and support them. We are not sure what the agenda of this centralized AI systems is, but they are there collecting data and basically promising that they will do it even more. Let's see if the dynamic, distributed, adaptable systems might actually help people to not being, well, exploited in that data sense by these AI systems. And yes, let's talk about the role of the people, about sharing data, about owing. Basically, you can actually own data. Who does that? Governing data is another topic which is really important, because it goes well above our capacity to do so. So this will be the topics for the next time. And yes, I have sent in the chat 2 links. One link is a survey, but it is related to a short video of me and another person crossing the red light and basically asking you, how do you feel about sharing that information if you were the one who was doing that? And by saying that, I would give the last word to Massimiliano to close the interaction.
Yes, thank you, Igor. I would like to thank you all for being here. I would like to thank Andy and Žan for participating to this discussion, and Igor that has invented this kind of very dynamic discussion and open discussion. And we see you next time.
Okay. See you guys. It was wonderful to hear from everybody. Yes, if you had some direct interactions with somebody in the group or outside of the group, then the mission was accomplished.
Igor, when is going to be the next
Alfonso.
one?
Yes, the second Tuesday of April is 11th April.
Yeah.
How do you feel about the 11th April, guys, girls? Yes?
Yeah, it's fine for me.
The same
Sounds
time?
good. Sounds
Same
good.
1 hour, and then we're off to other
Okay.
duties.
Perfect.
Yes. Okay.
Right.
Love you all.
Thank you.
Thank you
Bye-bye.
very much.
Bye-bye. Thank you.
Thank you, everybody.
Bye,
Thank you.
bye everybody.
Bye. Bye.
Um,
Bye.
Bye.